This is a Joule thief, and it can do one of the most amazing things of any circuit I've seen. What you see before you is a dead AA battery with less than a volt left, but it is going to solely power this entire circuit, including a 3-volt LED. How is this even possible, I hear you saying? Well, the main concept that drives this is Lenz's law. Lenz's law states that, quote, the direction of an induced electric current in a conductor is always such that it opposes the change in magnetic flux that produced it. This means that if a copper coil or another magnetic material is suddenly brought really close to a magnetic field, it will start producing its own to counteract that of the magnets. Here's what the schematic looks like when it's running. As you can see, there's a 1-volt battery powering first into the 2 coils, which split off. Looking at the first path, we see that you go first through a resistor and then into an NPN transistor. This transistor is active when a positive voltage is applied to the longer lead. The second path, going through primary, leads instead into this LED, switching it on. Now let's have a look at how it actually flows. As you can see, current flows first through the transistor, builds up speed, and then is dumped through the LED. This happens because as current's flowing through the primary, it builds up an electric field, eventually stopping current through the secondary. This then forces all of that built-up energy through the LED. Then, with nowhere else to counteract it, the magnetic field collapses, forcing huge amounts of voltage directly into the LED, turning it on. The problem is, this collapses the magnetic field, and suddenly there's nothing stopping the secondary. Current returns into the secondary and turns back on the transistor, restarting the cycle anew. As you can see on the lower half of the screen, this creates repeating waves of energy being built up and released over and over again. So now you've learned how to power an LED with a dead battery. But before we go, let's have one last look at the final device. Beautiful, isn't it?